Okay, hi everyone. Today we'll be doing on a topic on salt preparation. But before going into the topic, I would like to review some concepts. So, okay, so before before I go into the topic, I'd like to review the top. Okay, so before we go into the topic, I'd like to review the solubility of salts. So it's the solubility table. Okay, so this is something that you would have to memorize, but I usually memorize it in such a manner which I feel would make it a little bit easier. So first of all spar salts, nitrates, and your group 1 elements, they are all soluble. Okay, so spar here actually represents sodium, potassium, and A represents ammonium, not aluminium, but ammonium. So for example, sodium chloride, potassium chloride, ammonium chloride, they are all spar salts, or sodium hydroxides, potassium hydroxides, ammonium hydroxides. Yeah, so these are all spar salts. Next, I will group the chlorides and the iodides together, and they are all soluble as well. Except for your lead and silver, meaning sodium chloride, magnesium chloride, zinc chloride, any chlorides, they're all soluble except for lead chloride and silver chloride. These are insoluble. The same for iodides. All are soluble except for lead iodide and silver iodide. These two are insoluble. Okay, next will be sulfates. Similarly, all sulfates are soluble except for barium, calcium, and lead. So same idea here. For sulfates, any sulfates are soluble except for barium sulfate, calcium sulfate, and lead sulfate. Okay, now I will draw a line. So what we've talked about so far are this. The spar salts, nitrates group 1, they are all soluble. Chloride iodides, all soluble except lead and silver. For sulfates, all soluble except this. So far so good. Now, what about the rest? Right, so I'll conveniently group the rest as your oxides, your hydroxides, your carbonates. So for all this, which I call the rest, it's a little bit different. They are all insoluble. Except your spar and group 1. So basically, they are all insoluble. But we know that your spar, nitrates, and group 1s are always soluble. So that's why you get that they're all insoluble except your spar and group 1. Okay, so basically this is what we need to know for the solubility table. Keep this in mind, review them, and eventually you would have to memorize them. It would be easy after a while. This is usually how I remember them. The soluble ones, the insoluble ones. So I remember only the insoluble salts. Yeah. Okay, with this in mind, let's begin. No. Right, let's begin our topic. So yeah. Okay, maybe I won't touch it. Okay, So far so good, right? Okay, good. So the solubility table, we are done. Okay, now let's move on. Having now already understood the solubility table, we can now talk about the methods to prepare salt. So how do we prepare salt? How to prepare any salt. So after this topic, I hope that if I were to give you any salt, you would be able to describe to me the reagents I would need to make the salt, as well as the steps required to make the salt. And it would be good if you could explain to me the rationale behind using those reagents and why other reagents may not work. Okay, so the first question we always ask ourselves is whether or not the salt is soluble. Is it soluble or is it insoluble? Okay, if it's insoluble, we immediately use the precipitation method. If it's soluble, we would use, if it's soluble, we have to ask one more question. Is it a spa salt? Or is it not a spa salt? Alright, so I hope by now you could understand that spa here actually means sodium, potassium and ammonium. So if it's a spa salt, we would use titration. Otherwise, we would use the excess method. Again, excess is not a real word. I would just call it the excess method and we would see why later on. Okay, so far I hope the schema is very clear. To prepare any salt, we have to first ask if it's soluble. If it's a soluble salt, we would further ask if it's a spa or it's not a spa salt. If it's a spa salt, we would use titration. If it's not a spa salt, excess method. Otherwise, precipitation for insoluble salts. Okay. So, each of these three methods. Now let's go into detail. Okay, let's start with precipitation method. Our first method, if you remember, it's for your insoluble salts. Precipitation methods is for your insoluble salts. So, let's say for example, these are my reagents and this is my product. I would like to prepare salt C, which I know is an insoluble salt, so I call it as solid. The question now is, what reagents should I be using? Before we determine the reagents, let's first explain the rationale. So would you want to have both of A, B reagents being solid, one solid, one aqueous, or both aqueous? Let's think. If I were to add both of them as solid, there would not be any reaction. It's like adding Milo powder with coffee powder. There's no water, there is no aqueous solution, there wouldn't be any reaction. So these two, they're not possible. There will be no reaction. What happens if I add aqueous with solid? Will there be a reaction? There is aqueous solution. There's likely that there will be a solution, a reaction. But the problem is that at the end of the reaction, so say for example, I throw in A, I throw in B. They reacted to form C. But there could be A or B left behind. Which means that what is left behind would be an aqueous solution, a solid, and a solid solution. And I will have some problems separating this two solid solution. So I would have while there will be a reaction, I will have difficulties trying to separate B and C. So no, it's not the best method. Let's look at the third one. If I have aqueous and aqueous getting together and I produce a solid, I hope you're able to see that this is the best method, because unlike the first two methods, this method will react and it doesn't matter how much of A and B I add, because ultimately C will be produced. C being insoluble could be easily separated. So this is the best method. So I'll be using two aqueous reagents to form my product, and then I'll later separate them using a filtration method. So next question would be, since we need to be using two aqueous or soluble salts, what reagents should I use? Well, I know that according to the solubility table, all nitrates are soluble, all spar salts are soluble. Okay, all nitrates and spar salts are soluble. So if I were to prepare, say for example, silver chloride, prepare silver chloride, what would I do? Well, I would have to first determine that it's an insoluble salt, so I'll be using the precipitation method. And as we have said earlier, the precipitation method requires both aqueous salts. So I could easily be using silver nitrate reacting with a spar salt, sodium chloride. Right? Both are, as we know, aqueous salts. So when they react, alright, so what reaction is this? We'll talk more about it later on, but for now, let's just understand that silver chloride will be formed, which is my solid, and sodium nitrate will be formed, which is aqueous. Could you see that this is aqueous, this is aqueous, this is aqueous, but this, which is what I want, is a solid. So very easily I can separate them. I could separate this out using a filtration method to obtain the residue. I could do a filtration method to obtain the residue, and the residue here would be my silver chloride powder.